We're now going to get into taking the derivative using the chain rule. Now, if this is f of x and we're asked to find f dash of x or f prime of x, note this thing here inside the parentheses is not just a single variable x, which we know how to deal with. So let's make this an easier problem. We'll say let u equal whatever's in parentheses. And now this equation turns into y equals u squared. So if we let u equal this, then I have u squared. I can find the derivative of y with respect to u, which is written like this. dy du is, well, that's just the power rule. Multiply and subtract 2u to the first power. Now, u is equal to x squared plus 1. So let's find the derivative of that. We have to find the derivative twice. So if u is defined in terms of x, then its derivative, by convention, is du dx. And that's just the power rule then. 2 times 1, 2x to the first power. And then, of course, the constant goes away. So here's the chain rule. dy dx. That's what we're after. If this is y, original f of x, so look, y is written in terms of x. So we want to find dy dx. Well, dy dx is equal to dy dx. Oh, dy dx is equal to dy dx. Of course it is. Here's our middle man or middle woman, du. You can see that the du's will cancel out and we have definitely a true statement. So now we can make our substitutions. dy dx is equal to, well, what's dy du? It's 2u to the first power times du dx. Well, what's du dx? Times 2x. Of course, we don't have u's, do we? dy dx is equal to, what was u? We said that's 2 times whatever u is equal to times 2x. And we have u equal to x squared plus 1. 2x times 2, we can just clean this up a little bit, right? 2x times 2 is 4x times x squared plus 1. If you want to distribute that out, you can. And there's our answer. This same problem, using the chain rule. I'm not kidding. I am using this rule, and I know that can be a little bit confusing. What do? If we want to find the derivative, y prime, and this isn't just x, treat it as if it were a giant x. So use the power rule, 2 times whatever's in parentheses to the first power, and we're going to tag on the derivative of whatever's in parentheses. So this is x squared plus 1 times the derivative of that is 2x. Gives us y prime is equal to 4x times x squared plus 1. So in practice, once you understand what's going on, in practice it's not too bad. One thing to notice is whatever you had in parentheses here, you'll find it in the answer. It remains unchanged. And the additional step is that we're going to be multiplying by the derivative of whatever's in parentheses. This begs the question, is the chain rule new to us? If I have y equals 4x to the third, let's use the chain rule. Let's put x in parentheses. And so we say y prime is 3 times 4 is 12, whatever's in parentheses squared, and then we'll tag on the derivative of whatever's in parentheses. Well, the derivative of x is 1. Ah, look at that. We actually have been using the chain rule the whole time. But if we have just x in the parentheses, its derivative is 1. And so we really don't need to tag it on, do we? Find the derivative of y equals x squared plus 1 cubed. Oh, shoot. This is a chain rule problem because this is not just x. So I said let u equal x squared plus 1. So this turns into y equals u cubed. Y in terms of u, so that means our derivative here, dy du, is 3u squared. U in terms of x, that means du dx is 2x. Chain rule, dy dx is equal to dy dx. Oh yeah, the middleman is du. So dy dx is equal to dy du, 3u squared, times du dx, which is 2x. Now, notice I didn't put u, did I? U is equal to x squared plus 1. So what's our derivative here? 2 times 3 is 6x times x squared plus 1 squared. There's our derivative right there. Now, did I really need to write all of this out? Well, if you understand that this is not just x, so use the power rule. 3 times whatever's in parentheses squared, and then you'll tag on the derivative of whatever's in parentheses. X squared plus 1 times s derivative is 2x will give us 6x times x squared plus 1 squared. It's a lot faster that way. Find the derivative. Notice this is not just x. So I immediately say let u equal 14 minus 6x. Turns my equation into y equals u to the fourth. So dy du is 4u cubed. And here I have du dx. U is written in terms of x is going to be negative 6. So dy dx is dy du times du dx. So dy dx is, well, dy du is 4 times u cubed, and du dx was negative 6. And what was u? We defined u as 14 minus 6x. So I could make this negative 24, 14 minus 6x cubed. And there is my derivative. Now that is the chain rule. Could I do this without actually going through the steps of letting u equal something? Sure. I just recognize that's not just x. So dy dx, y is written in terms of x, so our derivative is dy dx is equal to, use the power rule, 4 times whatever's in parentheses to the third power. Now I'm going to tag on the derivative of whatever's in parentheses and leave whatever's in parentheses unchanged. So of course that's the derivative of this is negative 6, so we get negative 24, 14 minus 6x to the third. And of course we can find the derivative much faster once we understand this chain rule. Find the derivative of this. I recognize whatever's in parentheses is not just u. I'm sorry, not just x. So I label it as u, 10x minus 1. So y is equal to u to the fourth. Y written in terms of u, that means dy du is 4u to the third power. If u is written in terms of x, then du dx is simply 10. So I know dy dx is equal to dy du times du dx. Looks like du is the middleman there. Dy dx, our goal is equal to 4 times u to the third times du dx, which is 10. Notice du dx is just the derivative of whatever's in that parentheses there. We defined u as 10x minus 1. So this will give us 40 times 10x minus 1 to the third power. That's our derivative. Could I do this without defining whatever's in parentheses as u? Sure. This is going to be, just treat this as one unit. 4 times whatever's in parentheses to the third power, and tag on the derivative of whatever's in parentheses. 10x minus 1 times 10. So you can see I can get the derivative using the chain rule without doing all that extra writing. There it is, just as we got before. If we're asked to find the derivative here, notice this is the square root written as a fractional exponent. 10 minus x is not just x, so I'll use the chain rule. I'll call this u and let that be 10 minus x. So y equals u to the 1/2 means that dy du, the derivative here is 1/2 u to the negative 1/2 using the power rule. And here du dx is simply negative 1 using, again, our power rule. So dy dx is equal to dy du times du dx gives us dy dx is equal to, well, this is 1/2 times whatever u is equal to the negative 1/2 times du dx, which is negative 1. And what did we define as u? 10 minus x. So if we clean this up a little bit, negative times negative is negative 1 on top. 2 goes on the denominator, and this is the square root of 10 minus x. So there is our derivative using the chain rule. Could we have arrived at the same answer without using dy dx equals dy du times du dx? Of course. Just recognize this is not just x, so treat it as one unit. use the power rule, 1/2 multiply and subtract. So 1/2 minus 2/2 is -1/2. And notice, whatever I have here, I'm going to tag on the derivative of it. And that's what I'm doing. I'm chaining it up. So times -1 gives us -1. Again, we get the same answer, 2 over the square root of 10 minus x. Either way gets us there. If we're asked to find the derivative here, immediately we know we're going to have to use the chain rule because whatever's in parentheses is not just x. So I'll make this an easier problem by letting u equal 2x minus 3. So that changes my problem to y is equal to u to the -2. Y in terms of u means our derivative here is dy du, which would be -2u to the -3 when I use my power rule. And if u is written in terms of x, then the derivative here is du dx is equal to 2. So my chain rule is dy dx is equal to dy du times du dx. Well, dy dx is -2, whatever u is equal to the -3, and du dx is 2. So what was u? We said that was 2x minus 3. So I get 2 times -2 is -4 over 2x minus 3 to the 3rd power, because that negative exponent just means I'm in the wrong place. Put me down in the denominator. Could we do the same problem without using dy dx is equal to dy du times du dx? Of course. Recognize that this will be treated as one unit. So our derivative will be multiply -2 times whatever this is and subtract 1. And then we're going to tag on, the chain rule says take whatever's in parentheses and tag on the derivative of what's inside the parentheses here. This is actually du dx. So this remains unchanged, and the derivative of that is 2 to give us -4 over 2x minus 3 cubed. Much quicker that way, right?